Yeah, good day, guys. How's it going? We are talking about expanding two brackets today. Now, for expanding one brackets, we always know how to do it. Let's say we have 2 times x plus 3. So to expand one bracket, you just literally just multiply everything inside this bracket by 2. So 2 times x and 2 times plus 3. Remember, the plus belongs to 3, so there's no surprise about this. And after this, we're going to have 2 times x is 2x, and 2 times plus 3 is plus 6. So this is how you quickly expand the brackets. Um, but now, when we're talking about expanding two brackets, firstly, you've got to have some concepts about um, multiplying, why we multiply, because multiply goes faster than adding. Um, but let's wind back a little bit about the measurement that we did before. The area of this rectangle. Oh, it's not drawn perfectly, but you know what I mean. So this is the length, and the length go from here to here, and this is the width, and the area is how much is inside this rectangle. So the area of the rectangle, area is going to be length times width. Okay, so now you all know about the area of the rectangle is length times width, and we're going to use this idea to talk about expanding two brackets. Um, let's start with a different example. Okay, so let's say today you're trying to expand x plus 2 times x plus 3. You've been asking yourself, okay, what's going on here? Let's use the picture above as the example. So if we imagine x plus 2 is the width and x plus 3 is the length, you are literally looking for the area of a rectangle, right? So if you can imagine x plus 2, I mean the whole thing here is the width, and the whole thing here, x plus 3 is the length. So literally you are just looking for the area of the rectangle, which we about to do it now. So you can imagine x plus 2 as width and x plus 3 as length. So how do we do it? How do we get the area of the rectangle? Here we go. So we need a bit of help from geometry. Let's just draw a big rectangle here. Okay, no worries so far. It's a rectangle. Even it doesn't look like a rectangle, in your mind, it is a perfect rectangle. So I'm gonna divide this rectangle into pieces, and I'm gonna call things, right? So I call this guy from here to here is x, yeah, for sure, right? And this from here to here is also x. Well, you can clearly see the first shapes is a square, or it's just it's a special rectangle. And then I'm gonna label this side from here to here. It's gonna be plus 3, and then from here to here is plus 2. Okay, so the area of this first, so we're gonna label this one is the area number 1, area number 2, area number 3, and area number 4. So the area for number 1 is gonna be, well, x times x, right? Which is x squared. The area number 2 is gonna be 3 times x. This could be 3x, because this is 3 is the length and x is the width, as you can see here. Draw another one here. See? So length is 3 and the width is x. So that's why the area of the rectangle number 2 is 3 times x, which is 3x. And then similarly, the area of number 3 is gonna be 2 times x, which is 2x. Okay, here we go. And the area number 4 is literally just 3 times 2 is 6. Well, I can label it again down here. So this is plus 3 for the length of 4, and this is plus 2 for the length of the width. So we got those 4 areas will make up the big area. Well, you can clearly see that the big area is um, this one up here, the one I highlight in pinky color. So this is the width and length of big areas, as you can see from the picture. So, but the big area is made up of 4 small areas. So now, if I add those 4 small areas together, I hopefully will have something special for you. So here we go. So if I add these all 4, add these things together. So I'm gonna add this guy, this guy, this guy, and this guy together, and see what I have. Because 4 small areas, 4 small rectangles make up a big rectangle. So I got x squared plus 3x plus 2x plus 6. Okay, so I got x squared plus, now I simplify a little bit. So x squared just goes by itself. 3x plus 2x gives me 5x and then plus 6. So this is my final answer to the area of the big rectangle. In fact, when I expand x plus 2 times x plus 3, I have this. There you go. And you wonder, if you understand, it's good. If you don't understand, make sure that you rewind a little bit and check out the explanations. Okay, so we have that. But the real question is there a quicker way to do this? Yes, we have. Okay, so a quicker way to expand these things is using the column method. You have it replicates the area idea, so it will look like the area, but it's not really the entire picture of the area, maybe part of it. So I put um, so again you will see the idea of the area is done here. So I connect these 4 here together, make sure it looks like the area big rectangle. Up here I give an x, put x, this one I put plus 2, in here I put x, I put plus 3. So in each square I'm gonna find the area, so x times x give me x squared, and for this one I have plus 2 times x is plus 2x. In this area, this rectangle area, I got plus 3 times x is plus 3x again. And in this final rectangle here, I got plus 3 times plus 2 is plus 6. And now I'm going to make sure that I add them all together. So x squared plus 2x plus 3x plus 6 to give me, the overall area, which is the one that I want to expand. And now I put them together, x squared plus 5x plus 6, easy peasy, that's it. So this is, in fact, the expansions of x plus 2 times x plus 3. We're going to go over one more example, and we're going to seal the deal with expanding 2 brackets. Okay, let's go over a very different example. So let's say we want to expand x minus or 2 times x plus 5. In here we have minus 2 plus 5. Seems a bit difficult, but no, it's not really. So again, we use the same rectangle idea. We're gonna set things up like this. Make sure the center is a rectangle itself. There you go. So on top I put x minus 2. I put minus 2 in one column just because the minus belong to 2. It's just that. And down here I do the same x plus 5. Same idea, right? So I got x times x is x squared, minus 2 times x is minus 2x, plus 5 times x is plus 5x, and lastly, this rectangle area is plus 5 times minus 2 is minus 10. So overall, you're going to have x squared minus 2x plus 5x minus 10. There's no more x squared, leave x squared here. And now I'm going to highlight minus 2x and plus 5 because I can put them together. So if I put them together, I have minus 2x plus 5x is plus 3x and minus 10 just by itself. So in fact, you have x minus 2 times x plus 5. It's going to be equals x squared plus 3x minus 10. And as you can see on the right hand side, there's no more bracket. So we have successfully expanded 2 brackets. Yeah, it's just that, really. In fact, if you are curious to see if there is even a quicker way to do this, we're gonna go ahead, we call it double rainbow techniques. Remember how you expand 1 bracket? You use the double rainbow. So we use double rainbow. So it's like 2 double rainbows. Okay, let's get to it. Let's talk about the same example and see how we can use the double rainbow techniques. Minus 2 plus 5. The minus still belongs to 2 and the plus still belongs to 5. There's no argument about it. So double rainbow for the first one, and then double rainbow for the second one. There you go. So let's do the top one first, the top rainbow first. So it's going to be x times x because I do the arrows, it means I times. Just like when you do it as single brackets, when I do the hook, the arrows, it's mean times. So x times x give me x squared, and x times plus 5 is plus 5x. And now I do the bottom rainbow. So I have minus 2 times x is minus 2x, minus 2 times plus 5 is minus 10. So there you go. And now it's the simplifying business. So I put plus 5 and minus 2 together. X squared and minus 10 stays because there's nothing in common between them. So plus 5x minus 2x is plus 3x and minus 10 stays. So look guys, we have the same answer, a little bit faster, I'll say, but it's entirely up to you to decide which method do you want to use. So if you want to use the area method, which is up here, it's fine. Otherwise, you can use the double rainbows down there. So depending on which one you're familiar with, yeah. Otherwise, that's pretty much for today. We'll see you in the exercises.